Hey guys, and welcome back to another video on the channel. In today's video we're going to be pretty much looking at the introduction to factorization. So this is kind of a pre-topic before math methods. Before you start using quadratic equations, you probably should learn how to factorize. So factorization, we've done it in the past pretty much. It's pretty much taking something that's common out of an expression. So let's read their general thing for factorization. So if each term in an algebraic expression can be factorized, it contains a common factor. So for example, if we had, let's say, 5x squared plus, let's say, 25x, what's common in that is x and 5. So I can take out a common factor of 5x, and what I'm left with is, well, x and pretty much 5. So that would be an example of factorization, because if I were to distribute this common factor to all this stuff here, I would get the result above, pretty much. Then this is a common factor, is a factor of the entire expression. To find the other factor, divide each term by the common factor. The common factor is then placed outside the bracket, so like this here. So this process is known as taking out the common factor outside the brackets. Pretty basic explanation, but that's about it pretty much. Let's get straight into doing some examples. So for example, example 8, factorize 9x squared plus 81x. So we'll just write it here. And let's see what's common in there. So 81 is divisible by 9. So straight off the back, I know 9 can get taken out of. And I also see, alright, there's an x here and there's an x here. So I can take that out as well. So let's just try with, alright, 9x. So if I take that out, what I'm going to be left with is x. And here, if I were to multiply 9x to something here, it has to be 81x. So that has to be positive 9. So let's double check that. So I've taken that common factor of 9x. So if I were to re-multiply that in, I'd get, alright, 9x squared plus 81x. So we still have pretty much the same thing. And that's pretty much it factorized. Pretty basic, I know, but I thought having a video on this would be helpful to some people. Okay, so B factorize this following expression here. So this one's a bit different because we've got two variables. Because we've got a squared and, we've got a and x. So we have 2a squared minus 8ax squared. Now, what I cannot factor out is any x's because there's none here. I can factor out a 2 because 8 is divisible by 2. I can also factor out an a, but I can't do more than 2 a's because there's only one here. So what I can factor out, alright, let's factor out 2a. So 2a, what I'm going to left here is just a, and here 8 divided by 2 is going to be 4, so minus 4, get rid of the a, and then x squared. Right. So I can't see anything else I can factor out, and let's see if I multiply this out, I get the expression above. So if I multiply this and this, I'll get, alright, 2a squared minus 8ax squared, and that's it pretty much. That's that example done. Let's move on to the next one. So factorize 7x squared y minus 35xy squared. So let's just write that out. So 7x squared y minus 35xy squared. So we can see we've got two variables again, and we can see we've got one of each. So immediately I can see, alright, I can factor out an x and a y out of both of them. Now I can't factor out more than 2 because this is x squared, but this is only a y, and this is only x and this is only a y squared. So straight off the back, alright, I can take out a factor of x and y. So what I'll be left with is 7x minus 35y. Now let's see what else. Can I factor out anything else? I have to look at pretty much the numbers now. So 7 is 35 is also divisible by 7, so I can take out a factor of 7 as well. So if I take that out, that'll be 1. 35 divided by 7 is 5, I believe. So this is what we have when we fully factorize it out. Now we can double check. If I multiply this back out, will I get the expression above? So I'll get 7x squared y for that first term, and then for the second term we'll get 35xy squared. Yep, so that's everything. So that's fully factorized there. Let's move on to the next example. So factorize this. Righto, so this one is a bit trickier, and this isn't something you'll see more in math methods. Like, obviously you're going to have stuff like this. That's just basic stuff you need to be able to do. But stuff like this is going to be a bit harder to factorize. So, at the start, you're probably thinking, how are we going to factorize that? Well, this is a thing we're going to have to do. It's called pretty much grouping. So, just look at these first terms and these terms here. Treat them separately. So, x cubed plus 4x squared minus 3x minus 12. What we want to do is pretty much isolate things. So isolate the front and the back pretty much. So what we're going to do is factor out something out of here and something out of here such that I get two things that look pretty similar. So at the front bit, I can't factor out a 4 because that'll be a quarter. Well, you can, but it wouldn't be a nice thing to do. But I can factor out an x squared for start. So I get, right, x squared on x plus 4. So that would be that front bit there. And now when I look at this back bit here, I want to try and turn this, I want to factor something out such that I get this thing here. And then I can factor out x plus 4. So what I'm looking at here is, alright, I know if I factor out negative 3, I'm going to get positive 4 here. So let's just try that. So that will be minus 3, x plus 4. So what we've done is change how our thing looks. It's still the same algebraic expression, it just looks a bit different. But now, what I can see is in the entire thing, alright, I've got a common factor of this here and this here. So what I can do is factor that out. So in other words, I'll have x plus 4 multiplied by x squared minus 3. And that is that polynomial factorized. And you're probably thinking at the start, if you hadn't seen that before, how would you even start that? Well, what we're going to do now is, alright, if we multiply this out, we should get this following expression up here. Hopefully. Let's see. So, if I take this up here, and all you do is FOIL method. So this needs to be multiplied by that, and this, and this. So, first term, x times x squared is going to be x cubed. Got that? X times by minus 3 is going to be minus 3x. Got that? 4 times by x squared is going to be positive 4x squared. Got that? And then 4 times by minus 3 is minus 12. Got that? So, we've successfully factorized that. So, the way you do it is you look at the whole polynomial and think, alright, group the larger terms together and these two small terms together. See what you can factor out here, and then try and turn that into this thing down here by factoring out something, pretty much. I think there's a couple more examples like this and we'll have a go at them together. If you have any questions, try and leave some in the comments and I'll try my best to answer them, alright? Righto, so A and B, what we got here is, alright, this looks a bit funny. We want to factorize this and this. Now, at the start, we're looking at that and thinking, okay, how are we supposed to really factorize anything? We've got 3x squared minus 75. 75 is it divisible by 3? I don't think so. 75 divided by 3, I'm just going to double check. Oh, it is. So you can factor out a 3 if you want. And you can have an x squared. 75 divided by 3 I think is 25, so you have minus 25. And you're probably thinking, alright, what do we have here? What we actually have here is a difference of squares. So, in other words, if you have a squared minus b squared, that is the same as a plus b multiplied by a minus b. So let's double check that. If I multiply this out, let's see what we get. So first one, you're going to have a squared. Second one, you're going to have minus ab. A times negative b is going to be minus ab. Then you're going to have b times a, so positive ab. And then you're going to have b times by negative b, so minus b squared. And we can see that cancels that, so we get a squared minus b squared again. So we've got that exact same setup, except in this case here, your a is x and your b is 5. So x squared minus 25 is the same as, right, x plus 5 multiplied by x minus 5. If you were to multiply that back out, let's see what you get. You get x squared minus 5x plus 5x minus 25. We can see those terms cancel out and you get the expression on the left. So what we can do is the exact same thing here. So I'll rub that out real quick. So we can write that as, alright, 3, and then write this following expression, x plus 5 multiplied by x minus 5. And that is a fully factorized, pretty much. Okay? Now let's do the same thing with b. Let's rub this out, so room. So b is going to be 9x squared minus 36. We can see 36 is divisible by 9, so if you take that out, you're going to get 4. So you can take out 9 straight away, so x squared minus 4. And we can see we have another difference of squares because x squared minus 4 is the same as x plus 2 multiplied by x minus 2. So we're going to apply the same thing here. So 9 multiplied by x plus 2 multiplied by x minus 2. So this is called a difference of squares, if you haven't seen that before. Let's see if I can spell squares correctly. Squares, I think that's how you spell it. I don't know, I don't trust myself. But anyway, so search a difference of squares if you haven't seen that before. I might make a video on it, but that's how you factorize these two guys here. Let's move on to the next example pretty much. Oh, that's the previous one. Alright, factorize the following. Actually, I think I might leave it for that video because I don't want to make this one too long. It's 10 minutes. So I'll see you in part 2 where we'll be starting example 12. And then we'll go through the rest of them pretty much. I hope you enjoyed this quick little video, and I'll see you in the next part.